Well, hello. Today we are going to be talking about compound interest. Now, compound interest is a way of earning money while you have some money invested, maybe say in a bank. That's the most common area where you think of compound interest. And ultimately, what it means is it's just getting interest on the interest. So if you're earning simple interest, if you have $100 invested in the bank at 5% interest, then you would just take that $100 times the 0.05 times however long it was. Maybe we'll say, 3 years. And so at the end of this 3 years, you would earn your 5% and you would have $115 in the bank. But the way that compound interest works is it's done over a certain period of time, and so maybe they give you a little bit of that money, after 1 year. Maybe they give you some of that money after 1 year. They give you 1 year's worth of interest, and you would have then $105 after 1 year, and they would take that times 0.05, and you're getting more and more interest. Now, it's not a lot for some of these smaller numbers and smaller periods of time, but we'll be looking ahead at this and seeing that this compounding is actually pretty powerful. And yeah, so let's go ahead and take a look at the formula. Now we know that simple interest has a very easy formula. It's just the interest equals principal times rate times time. We've done that in the past. But compound interest looks more like this. Now, it's not as bad as what you think, though. That's the final amount that you'll have after T years. If we're going to put the money in the bank for 7 years, this will be how much your account says that you have. P is the starting amount, the principal amount, right? We did that already. Here we have R, that's our interest rate. Remember, that's always expressed as a decimal. So if we were doing 5%, we would use 0.05 for the R. N, this is the one that's maybe a little bit new. This is the number of times that it's compounded per year. So if something is compounded quarterly, as banks often do, then you would put a little 4 in for the N. And if something is compounded monthly, then you would put a 12 in for the N. And you would put it in down here and up here. Don't forget there's a little N right there as well. So what they do is they take your interest rate, and instead of giving it to you all at once at the end of whatever time period that you're doing, they're going to split it up based on how many times it's compounded. Okay, if let's make it really, really simple. If you were going to be getting 12% interest on something, instead of just giving you that 12% at the end of the year, if they were doing it monthly, they would give you 1% each month. At the end of every month, they would give you 1% and 1%. And ultimately, what's going to happen is you're going to get more of an exponential growth instead of a linear growth. And so this compounding really does start to take effect after a while. Let's take a look at just a real quick example of how this might change. I just made a quick little Excel spreadsheet. Let's just say you invested $1,000 at simple interest, and you gave it to someone, and they said, "I'll give you simple interest, and after 2 years' time, I will pay you 12% interest here." So an APR of 12%. So what that means is 12% per year for 2 years. So if you just do I equals PRT, you would take 1,000 times, that's the P, times the rate, times 0.12, times 2. And that would end up getting you $240. So at the end of 2 years' time, and this is months, at the end of 2 years' time, they would give you back your original $1,000 plus the $240 interest. So that's simple interest. But ultimately, like what that means is over the course of this whole time, like you're not really gaining money. No money, no money. It's just that $1,000, $1,000, $1,000. And then right at the very end, they give you $240 interest. But if you were to put this in a bank that was compounding 12% interest, which would be incredible considering banks offer interest rates of like 0.01%, not 1%, like 0.01%. It's ridiculous. So you're not going to get rich by putting money in the bank. You've got to find someplace else to put it. We'll talk about that later on. But if you were to put money in a bank, then and at 12% interest, and they were compounding it monthly. Notice that I have 12 over here for number of compoundings in a year. So if they're compounding it monthly, that means that at the end of the first month in your account, you would have your original $1,000 plus a little extra money. And then plus the next month, they would take ultimately it's going to end up being 1% because they take the interest rate divided by the compoundings. And so the next month they would pay you and you would be getting a little bit more. Notice that first month you got $10 in interest. The second month you got $10.10 worth of interest. And the next month you got $10.20 worth of interest. The amount of interest you're making each month is actually increasing. That's because you're getting paid interest on the interest. And after so much time, you ultimately, after 2 years' time, you have $1,269.73. Now, you might say, oh, what? So what? $29 more. That's not that much. Well, this is only a 2-year time span. And if we were to run this out over 10 years, 20 years, maybe 40 years, like your working life, then this turns into a very significant amount, this idea of getting paid interest on the interest, and this idea of ultimately what is exponential growth. Now, this quick little spreadsheet I just threw together isn't meant for that. There's other things that we can do about that. I just wanted to give you a quick little idea of how that compares, and maybe if we do something more like 5%, which again, banks still wouldn't pay that, but you can see the difference isn't huge when we're talking about these small little numbers. Maybe $1,000 is huge to you, but when you're talking about retirement, you're talking about lots and lots of money, right? If you had $100,000 sitting in the bank, now we're talking about an extra $494. Again, still not a lot, but with time, it's going to grow into a whole bunch. So let's get back to it, and let's say we're going to invest $4,000 at 8.25% interest compounded annually. So we're going to use this idea of A equals P 1 plus R over N to the NT power. And I would suggest that you just get in the habit of putting this in parentheses. If you have a nice calculator, whenever you go to put this up there, it might stick the whole thing up there and you don't need parentheses, but I'm just going to tell you, you probably want to use parentheses. You'll always get it right if you put it in parentheses, whereas if you don't, it just depends on your calculator. So the principal, of course, is our $4,000. And then we're going to use 1 plus R. This I have to change to a decimal, so we move the decimal over 2 places. 0.0825. Yes, we need all of it. 0.825. Now it says it's compounded annually, so we're just going to put a little 1 here. Do you need to put a 1? No, but we're going to, because ultimately we can just end up changing this number. Then we're going to raise this to the 1 times 3 power. Now when you put this in your calculator, here's my calculator. If you have a TI, I get this all the time. People are like, well, I have a TI calculator, so I can't do anything that you did. No, the TI calculator is exactly the same. Maybe one button is in a slightly different place, but all the buttons are the same. There's some things, I use this Casio because I really like it. It does some things nicer than the TIs. That's okay. You use whatever you want to use. All right, so I'm going to put this in, and I'm just going to use 4,000 times, you don't technically have to put it, but I like to, 1 plus 0.0825 divided by 1. Again, you don't have to have that. Divided by 1. You can also use the fraction button. I'll show you that in a little bit. That's this one right here on the Casio. In the TI, you go to, they have a little fraction button too there. And then we're going to raise that to the parentheses 1 times 3 power, close parentheses. There you go. This tells us that at the end of 3 years' time, and we'll want to round this to the nearest penny, so we get $5,073.92. Okay. Notice right here, this caret, this little almost like half a triangle is a caret. That just means that we're going to raise something up in the exponents. So that's what this part is right here. Maybe you have a nicer calculator, and when you do that, it makes this like a tiny little font, and it actually writes it up there. That's pretty nice. Those nicer calculators do that. Okay. But ultimately, here's what this looks like typed out so you can see it a little better. Some people like to do this one step at a time. I actually prefer to put the whole thing in the calculator all at once, but you just got to make sure you put this in here. Okay. All right, let's take a look at another one here. Suppose you want to invest $4,000 at 8.25%, so same number, but this time we want to know how much do we have after 7 years. Well, there's only a couple things that are going to change, and that's really just the time value, right? It's still compounded annually, so when we set this up, we're still going to use everything's the same right here. Let's go back and look at our calculator here for just a second. Now, depending on your calculator, you might be able to even just go back and change one of these numbers here. Again, it depends on your calculator, but I'll just go back and do that. Change this over to a 7 and hit enter, and then I'm done. I don't even have to retype the whole thing in. So if you have a nicer calculator, you might be able to do that, or you can copy and paste what you have. But go into Google if you're not sure if your calculator does it. Again, these nicer graphing calculators typically will. I'm not going to go through all the different ones. If you have a TI-83 or an 84, 84 Plus, a Silver Edition, Casio Prism, there's a whole bunch of them. Just Google it and learn a little about your calculator. It'll make things a lot easier for you. Okay, so you can see here that ultimately we end up with this much. And I do want you to kind of pay attention to the fact that of this $69.67.15, $2,967.15 of that is interest. You get that simply by subtracting off your initial investment. Okay, so what we can do is our interest, sometimes a problem might ask you, hey, how much interest do you have? Well, if you were to write down $6,967, that would be wrong. That's how much money is in your account. So you can take the interest, it will be equal to the final amount minus the initial amount. And that's how you can find the total interest. Okay, the final amount in your account minus the initial amount. That's how you can find your total interest. All right, next we have another problem, and this is just to kind of show you how things change with different numbers of compoundings. Now, we've already done annually, so that one's kind of boring. Let's go to quarterly. Suppose you invest $1,000 at 6 3/8% interest. Now, that's a little tricky. I'll show you here in just a second how you can do that pretty easily. How much will you have after 5 years' time? So, of course, we're going to use this A equals P times 1 plus all over N to the NT power. Don't forget to put this in parentheses. I don't always write it like that, but you should. This is the interest rate. Now you might say 6 3/8. What? Okay, well, all you got to do is just take 3 divided by 8, and then we'll add 6. And now we have this. This 6 3/8 is 6.375. Now you can change this to a fraction to a percent by moving this over 2 places. That's how I end up getting this for my interest rate. So when we plug this in quarterly, we're going to take 1,000 times 1 plus R, that's 0.06375, divided by the number of times. Quarterly is 4. Now I've got to raise that to the 4 times 5 power. Again, notice that that's in parentheses. Okay. Now, if you're not comfortable, maybe you don't have a nice big graphing calculator and you don't want to do this all in one go, that is just fine. Here, watch. So I've got this 6.375. Let me go ahead and divide that by 100 so it turns it into a decimal. Then we're going to say, let's just go through and we're going to do this all in order. So I've got 0.06375. I'll do divided by 4, enter, plus 1, enter. Now, do I do the multiplication or the exponents? Multiplication times 1,000, or do I do the exponent, the power? Well, according to PEMDAS, we do the exponents first. So I've got to now take that, and I'm just going to raise it to this power. Notice every time I just hit the next button, and it has this answer. That just means it's going to take whatever I just did, and it's going to do something new to that number that I got. So I'm going to raise that to the 4 times 5 power. Please put that in parentheses. If you don't, you will get it wrong. Okay? So we've got that, and now we take that times 1,000. So that's how you do these one step at a time. Oops, I forgot to take that times 1,000. Sometimes I hit the button on my calculator and it just doesn't go. Now it's gone. All right, let's do another one here though, and we'll do this one on the calculator. And again, I'm going to put this one in all in one line in case you do have a nice calculator like this. They're just a little bit easier to do. So we'll do 1,000, 1 plus 0.06375 divided by weekly would be 52. There's 52 weeks in a year, so we'll use 52. Then we'll raise that to the 52 times 5 power. Okay, so that's what we're going to put in the calculator. So we'll start out with 1,000 times parentheses 1 plus 0.06375 divided by 52. Close parentheses, so that's all inside my parentheses. Now I've got to raise that to the 52 times 5 power. Now, hopefully if I got all that in there, I should get a number that's really close to the one that I had. I should get something, all these should be really close to this, 1370 or so. But the more times you compound it, and if we round to the nearest penny, this will be 1375, 14. And the more times we compound it, the sooner we're getting the interest on the interest, then the easier, or the more money we make. It's not going to be a lot. And ultimately, this actually begins to approach a limit. And if you take some higher level maths, you learn all about limit. And there's something called continuously compounding. You don't typically find money that continuously compounds, but we use continuously compounding for things like population growth. I do want to do the daily one here because daily does tend to mess people up a little bit. You might recall that the Banker's Rule says that we use 360, not 365, whenever we're putting numbers in the denominator. Okay, so we always use 360 in a denominator like this. Okay, and then this will be raised to the 360 times 5 power. So let's go ahead and put that into the calculator and just take a look. All I'm going to do here, again, because I have one of these calculators that is a little bit nicer, maybe it'll let me do this. Yeah, I can just hit back, and it'll let me go back, and it'll let me change some things. So I'm going to go back to here, and now we'll try. There we go. So I can put in 360 in the denominator, so 0.06375 divided by 360. I got to move over, and I've got to change this one as well. Sometimes your calculators just type right over that, If you look around on your calculator, you might have this button, this INS, stands for insert. And if you do that, then that means that it'll actually do what my calculator is doing, which is it keeps shoving things over. So like the more numbers I write, it just keeps pushing things over. But sometimes if your calculator is not doing that and instead it's typing over something, why don't you look for insert? And then that will do what my calculator is doing now. Okay. So now we get 1375, 36. I know this is probably right because it's really close to this other one. The difference between daily and weekly is minimal, the number of compoundings that we're doing. Okay, so you should probably pick one or two more of these and just try it. I'm going to put the rest of the answers up here in about 5 seconds. So good time to pause and just try one of these on your own. Okay. Here's all the answers to them so you can go through and check them out. I think these are all pretty good. Here's a couple more practice problems. Again, I do want to just point out, you can see this is divided by 360 and then raised to the 360 times 5 power. So here's a little bit more practice with this. You can see we have 7.5%, so we'll use 0.075. We're only doing this one for 3 years, and ultimately go ahead and pick one or two. You don't have to do all of them, but just plug the numbers in, and I'm going to go straight to the answers here in a second. Okay, so good time to pause and try that out. Here's the answers. You can see that annually we get 69.56. And then the more times we compound, the more money we get. It's not a huge difference, especially once you get the difference between weekly and daily. Okay, quarterly and monthly, not a huge difference, but overall, you definitely get more the more times something is compounded. Okay. All right, now there's something called an APY, and if you ever decide to buy a house or take out a large loan for a car or something like that, and you look through the terms of the loan, you actually see this terminology, APY. So they'll talk about APR and then they'll talk about APY. This stands for annual percent yield. Okay, and all it is it's the same simple interest. It's a simple interest number that gives you the same amount as the compounded interest did. Okay, so let's go ahead and see. Look at this formula. Doesn't this look really familiar? It should. We changed the P to a 1. See, to calculate the annual percent yield, just treat it as though you're investing $1. And then if you invest $1 and go through and work out the whole thing, your interest rate is your original amount minus the principal. Hey, that's what we did just a minute ago. Remember when we were calculating interest and I said, hey, it's your final amount minus the principal investment. Well, if we want to find the interest rate, let's just pretend like we're investing $1. In other words, like 100%. It just works out well that way. Okay, so let's take a look at what that might look like here. Determine the effective yield of investing $1. In other words, we're going to be finding the percent rate, the APY. So we're going to invest $1 at 8% compounded daily. So this is just 1 times 1 plus R over N, that's 0.8, daily. That means we're going to be using 360 raised to the 360 times 1 power. Okay? Now, some of this is extra, and you just don't really need it. Like, we don't need to take 1 times this, right? You don't need to do the 360 times 1. I'm just trying to be consistent with everything that we did before. Okay? Now, when you do this, whoops, not that. That's something else. Calculator. All right, so when we do this, we'll take 1 times 1 plus, you do need this 1 plus 0.08, you need that in parentheses, divided by 360. Again, if you want to use the fraction button there, you can do that. And then raised to the 360 times 1. Boom. Okay, I get 1.08327774. There we go. But if you'll remember, in order to get our final rate, let's go back and look at it. The interest rate is actually equal to the amount minus the principal. And we're starting out with an initial $1 investment. So if I want the yield, meaning like how much it grew by, what I would do is I would subtract off 1. And that's how I get 0.0832774. Probably not all necessary. To try to write this as a percent, we would go 1, 2 places over. And that gets me 8.32774%. Okay? Now, that means if someone were to offer you paying you interest 8% compounded daily for 1 year, or if they said, you know what, we don't do compounded interest here, we just pay simple interest. And if they were to offer you 8.32% interest, simple interest for 1 year, then those two would be exactly the same. 8% compounded daily is equal to 8.32% compounded, or not compounded, but paid at the end of the year, paid simple interest. So this is exactly the same as this, 8% compounded daily for a year, 8.32% simple interest. All right, let's go ahead and take a look at this one. Why don't you try it, get your numbers written down, get them plugged into the calculator, and I'm going to show you the answer in 3, 2, 1. Here's the answer that I got. About 6.14%. You can round to whatever's appropriate in the problem. Okay, so there's the numbers. Take a look at it. Make sure they make sense. There's something called present value. What this means, if you have a goal in mind, like you want to end up with $1 million 20 years from now, then how much do you have to invest right now? How much do you have to invest today in order for something to be worth $1 million 20 years from now? That's what's called present value. Okay, how much is something worth today in order to be worth a certain amount sometime down the road? Now, this formula should kind of still feel familiar. Right? Look, if you actually multiply both sides of this equation by this bottom, if I take this times, oops, not times 1 plus r over n to the nt power on the left, and I guess that's on the right, 1 plus r over n to the nt. If we do that on both sides, boom, boom, that cancels. And now look at the formula that I have. It's a little hard to see, but it just really says A equals P 1 plus r over n to the nt power. This is the same formula. They just isolated it and solved for P. Honestly, I don't even really treat these as two different formulas. Treat them as one formula, put the numbers in, and then I divide when I need to divide. So that's how I do it. All right, let's take a look at a problem here where we're going to use this formula here. Will Hunting would like to save some money for his daughter to go to school. So he's going to put some money away. And he wants to know how much does he have to put away right now in a CD, a certificate of deposit. And if that CD is paying 4.72% compounded quarterly, how much would he have to put away right now? Now, if you were thinking about this in terms of the original formula that we were using, this A equals P 1 plus r over n to the nt power, you can actually just put everything in right here. We want our final amount to be 30,000. We don't know what the principal is, but we're going to use 1 plus 0.0704. 0.0472, and it's going to be compounded quarterly, so we'll divide by 4. And we're going to do this then to the 4 times 6, because it's 6 years from now. And you can see that if you put all this in the calculator on the right hand side, you know, let's just do that together. I'm going to slide this over. I don't know if it'll let me. There we go. Slide all this over here, pull up our calculator, and so you can do it a couple ways. You can take and plug everything into this equation, and that's just fine. No problem at all. Sometimes I like to just plug it in here, so I will do parentheses 1 plus 0.0472. Oops, looks like my 1 didn't go. I'll fix that here in a second. Raised to the 4 times 6 power. And I got to go back and put my 1 in. Sometimes I click the button, but it just doesn't go. Okay. Now, that's the right-hand side. Okay. And that number is way too big. So I definitely did something wrong here, and I see what it is. I forgot to divide that by 4. So ultimately, this actually would represent having it in there for 24 years because we didn't divide this by 4, but that's not what we want to do. Let's go back here. We'll put in a divided by 4. Yeah, that number looks a little better to me. Now, it's just because I have a lot of experience with this. I knew that other number was too big. So that's what the right-hand side of this is. One danger that some people have is they tend to write things down and they round things, and that's gonna do you bad. 1.325. Sometimes people will just write that down. They'll say like, oh, so maybe this is just 30,000 equals P times 1.325, right? No, it's not. You're going to get a different number. If I divide both of these by 1.325, I'm going to get something not right. Let me get the rest of this written down. 17185. Okay, so let's just say for a minute that, let's say we do this the right way, and I'll just show you how I would do that now, is I would put in 30,000 divided by, and the easiest way to do this is to hit second or shift and then answer. See down here that says answer? The TIs have it, most calculators have it, and that will then put this number right here, so you don't even have to write it out. This tells me that I need to save, or Will needs to save $22,638.57. Okay, and you should actually probably round that up to 58 cents. I'm not going to be super picky about that. You get the idea. $22,638.57. Okay. But let's just say for a minute that instead of using that whole big thing, let's say you got lazy, and I know you wouldn't, but let's say your friend got lazy, and they called you up and said, hey, I can't get the right answer to this. It's just not working out. And you look at their work, and they just have 30,000 divided by 1.325. They just rounded it because they said, it's probably good enough, right? No, look how far off we are. We're over $3 away. $22,641.50. Those extra decimals on here really make a difference. You can't round them. You can't get rid of them. Okay? So make sure that you either store that in the answer or you write down all the decimals. Now, the other thing that you could do is you can put this all in one line. You could say 30,000 divided by parentheses. Now, just to make sure, I'm actually going to do it again. Parentheses 1 plus 0.0472, right, divided by 4 because it's compounded quarterly. So that's going to be the part that's inside the parentheses. That's this part right here. Now I've got to raise that to the parentheses 4 times 6 power. And now I'll close my last set of parentheses. This one right here matches up with this one. That just means the whole thing is going to be put down on the bottom. Whoa, definitely made a mistake. Let's see if I can find it. Oh, I found it. See, I hit buttons sometimes, and they don't always go. Do you guys see my mistake? Can you look on here and see what my mistake is? Look right here. There's no decimal right here. That's the bad part about this particular uh, version of the calculator. Sometimes like I hit it, and maybe I didn't. I don't know. You can go through and watch the video. There we go. But now you can see we get the same exact answers we had before, $22,638.57. Okay, so that's how you can put it all in one. Again, you could also use the fraction button here. That'll work and makes it look a little bit nicer too. Okay, so there you go. I hope this helps a little bit with compound interest. This is how banks operate. They do work in compound interest. I know I personally, the bank that I the bank that I'm with is Wells Fargo, not sponsored, but if they want to, they can. They pay me, and I want to say the interest rate really is 0.01% right now, so it's virtually nothing. If you were ever told, oh, put money away in your savings account and let it grow with interest and compound, and then you'll have a lot more money later on. If you were, that may have been true with older generations because banks used to pay 4 and 5%, 6% interest. They don't do that anymore. So you're going to have to invest your money in other ways. Okay, CDs, government bonds, real estate, gold, stocks. There's lots of other places to invest your money. It's good to have some money in your savings account, but don't plan on getting rich from compounding interest. All right? All right, good luck with everything. Hope this has been helpful.